Alright, rabbits in the forest. We're this a bit late since I've been on the road, but I did check this out when it came on earlier, and I think I know what I would need to code here. So there's a forest of rabbits. There's going to be n rabbits asked. How many other rabbits have the same color as you? And collected an answer in an array where the ith index is the ith rabbit's answer. And given the array of answers, return the minimum number of answers that could be in the forest. So if the answers for 3 rabbit respondents is 112, the minimum number of rabbits will be 5 because each of the respondents that says there's one other rabbit that has my color, that's that'd be 2 rabbits right there. And then the rabbit that said that there's 2 other rabbits that are my color, that rabbit can't be the same color as the other 2, so there has to be implied that rabbit and 2 others. That's 2 plus 3, which is 5. So this is more of a math type problem than kind of a data structure one. I consider this more mathematical than anything else. Like, you just need to know the math behind it. The math behind this one would be for any response number, there can be that number. For any response number, there can be that many other rabbits that have that same response, and you can have a grouping of them that have the same color. So for instance, it's actually one more than that. One more than the response number is a grouping of rabbits that have the same color. So if the response is 1, then there could be 2 rabbits that have a response of 1 where they have the same color. If the response is 2, there can be 3 rabbits that have the same response and that same response having the same color. And if the response is 3, then there can be 4 rabbits that have that response. And so what you're really looking for is kind of the odd one out, because if there's like 2 1s, then there's no extra rabbits that are necessary. But there's 3 1s, then only 2 can get paired with the same color, and that third one would need to be would imply another that isn't there, or the odd 2 implies another 2 that isn't there. So the remainder of the response frequency plus 1. The remainder of the frequency, let's just code it here. So it's going to be n is the length of the answers. We'll need to have a counter for the number of frequency of each. I'll say frequencies is counter of the answers, which just gives us the mapping of response and how frequent that response is. And let's say, so for every, let's say, value of response in your frequency, the odd, kind of the odd one, the odd response will be the leftover amount of how frequent that value is modded by value plus 1. So for instance, there's 2 1s, right? And the value plus 1 would be 2. 1 plus 1 is 2. And 2 mod 2 gives you remainder 0, which means that there's no extra that's needed. On the other hand, like if the value was 2, the frequency there was 1, so that'd be 1 mod 2, or 1 mod 2 plus 1. 1 mod 3 is 3. Oh my god, 1 mod 3 is 1. And if there is an odd response, then you need to add the implied number of rabbits that are not part of it. So it'd be value plus 1 minus odd response. Yeah, I think so. And then just return the answer. Forgot to say answer is set to 0. Oh, whoops, answer is usually set to n. What am I doing? Ooh, so close. So here, one thing. I'm saying that there should be 3. And let's go and print out what each of these loops is doing. Value, answer. So 1, the frequency of 1 should be 2. 2 mod 2 should be 0. Oh yeah. I think here this should be if the odd response is not 0. I wonder if I should be able to make this without an if statement though. I should be able to make this without an if statement. So I don't want to just add 2. I want to add, if the remainder is 0, I don't want to add anything. But if the remainder is anything besides 0, like if the remainder is 1, I want to add the complement, the missing amount. So if it's 0, then I want to add 0. If it's 1, I want to add 1 in this case. If it was some bigger number, if the odd response was 0, still 0, but if it was like 1, then it'd be kind of like value plus 1 minus 1. So it's big value. Cutting down this if statement is what I really want here. So how does this work? If there is the remainder, you want the complement of the remainder. If there isn't remainder, you don't want anything at all. So what if you found the what if you found the complement first and then took the remainder? Yeah. What if you found the complement first? Yeah, so I think it might be value plus 1 minus odd response taken by another remainder. That might work. Oops. Oh, no way. 1 millisecond. Okay, there has to be something I'm missing here. There's some simplification to this calculation. I mean, I guess doing a couple modulations. So frequency of the value mod value plus 1. Well, okay, let's do some algebra here. So let's say x mod value plus 1. Okay, we'll say v1 is value plus 1. X mod v1, and then v1 minus x mod v1. All right. No, so this is odd response. So frequency of the value is, let's say frequency is f. So let's say x is this, and then answer is incremented with this. So if I did the substitution, answer is incremented by value plus 1 minus f mod v1 mod v1. How well do I know my modular arithmetic? I think you can distribute, kind of. So I think it should be v1 mod v, like v1 under all this is v1 mod, so I think this is the same thing as v1 mod v1 minus f mod v1, because modulating, is that correct? And then v1 mod v1 is obviously 0 though. And then you have answer plus equals negative f mod v1. That doesn't seem right. Answer plus equals the negative of the frequency mod. Okay, well, the math is the math. So let's try it. Answer plus equals negative of frequency, so the value mod value plus 1. I mean, maybe this is correct. Heyo. Ooh, Naparoo. Okay. Okay. Summary. Time complexity, space complexity. So again, the summary for this one is, so this is just a math problem, really. Quick calculation, or quick, where are you from, bro? I'm in California. Just a quick calculation is going to be the calculation based on the responses would group the same response value into groups of size r plus 1. Like, for instance, example response of 2 has groups of 3. So therefore, just add on to the count of responses the odd ones that do not form full groups. This is going to be based on the remainder of the frequency of that response by dividing by r plus 1. And then for each remainder, add onto the count of count for minimum number the kind of the complement of that remainder. So for example, if the remainder is 1 for response of 2, add onto it an extra 2. In general, that ends up being this math right here. But then you can simplify it to be this math right there. This is the basic math formulation, and this is the very condensed formulation of the above. All right, and then time complexity, this is going to be, this is just O of n. It's O of n. It's O of n worst case if all the responses are different. O of b, where b is the range of is the unique values of responses, because you're going through the frequencies, and the frequencies are just what different values you have in responses. And then space complexity, this is like O of n or v to make the counter mapping. All right. Cool beans.